This is a recording for the Coursera assignment, which asks to take a look at a data set of close to 10,000 observations and figure out what is the net hourly electrical energy output. So looking at the data, it appears to be fairly structured. It's in column, it's all numerical, and so a parametric algorithm seems like a good first approach here. And so uh, with that as a starting basis, what I've done is take a look at almost 10,000 observations and split into a training set, anywhere from observation 1 to 7,500, and the rest are what I called the testing set. You'll see them numbered out here. From this, the first approach that I took a look at was plotting each of these features against the output to see what kind of relationship there was. And you'll see, looking at output versus temperature, for instance, there appears to be a very strong correlation. This is again a linear plot. You see a coefficient or weight of minus 2.17 and a bias of 497 with an R-square value of 0.9, which seems to suggest that this is a good predictor of the output. We have similar kind of results for V. Again, linear relationship here with a bias and 0.755. When we take a look at AP and RH as features, not so much. You'll see here that the weight here is quite small, and even the R-square value is below 0.5. Same thing for RH. And so looking at both of these scatter plots, you can approach it one or two ways. One is keep it super simple and use a linear regression and just use AT as the individual variable, or you could go down a more complex path and try to do a multiple regression involving other variables. And so that's what I've done here. With the simple prediction, I determined what are the variable for temperature, essentially, and you see the weight here of minus 2.17 and a bias of 497. So using this function here and with temperature, I forecast a prediction of 425, which seems to be pretty good given that it's one variable that's used to calculate. The second thing I did was use multiple variables. This was AT and V, and using that's what you see. That's what you see here, MR prediction, apologies. The simple prediction is a single variable, and this is the multiple regression variables where you see the two variables out here. So those two variables were AT and V. Just right off the bat, comparing it to the actual results, it appears the simple prediction got closer than the MR prediction. And I test this out by calculating the absolute error between the simple prediction with the one variable or one feature and PE. And what I then do is average out all of the different error terms. You end up with a 1.2 error term. On the multiple regression, you can see that the difference is quite a bit over here. And so when you average it out, it ends up being 13. So overall here, it seems a simpler model works really well here. And it seems that using the one feature of temperature to estimate energy is the way to go. So that is all for this video.